Good morning, pre-algebra class. We are talking today about some special kinds of angles and angle relationships. We are going to begin with something that we haven't seen in a while. We haven't talked about it in a while, but that is parallel lines. So if we have two parallel lines, I'm going to draw them up here, kind of close to the top. Parallel lines, if you remember, they do not intersect. They are equidistant apart anywhere along the two lines. Today we're going to be talking about, because we've been talking about angles and angle measurements, we are going to create some angles here by cutting this through with another line. And something that happens here is that we create a situation where we have some special angles formed, some special relationships formed. I'm going to letter all of these so that we can look at them each individually, but you see all of these angles. We create 8 angles, and some of them have some special relationships. Some of these relationships you already know. One of them is vertical angles. Vertical angles are equal, okay? They have equal measures. So if I have, they are actually congruent. We call the shape of them is congruent, which means that their measurement is equal. Looking at this, can you see the vertical angles that are created here? Now, if you're looking just at the top, the two lines that intersect are the orange line and the blue line, and A and D are vertical angles. C and B are vertical angles. At the bottom, we have the same thing. E and H are vertical, F and G, and that means that if one of them is 110 degrees, A, then D is also 110 degrees, and you already know that, okay? Something that you need to know here is some terminology, though. That orange line, we call that a transversal. So this is two parallel lines cut by a transversal. That means that they cut down through those two lines, intersecting both of them, creating these 8 angles. Another thing that we know is that adjacent angles that create a straight line are supplementary. So look there and see if you can see which angles are supplementary. Okay, take a look at the top, the top blue line with the transversal. We have A and B next to each other, right? And they create a straight line or a straight angle. That means that if this one is 110, that has to be 70 because they are supplementary, and that means they have to add up to 180 degrees. We already know that. Easy. Some things that are new here, though, okay, are the way that these two lines relate to each other. If you look at A and E are on the same side of that transversal. You see that orange line there on the same side of it. They are also on the same position of those blue lines. So they are both in the upper left portion of the blue line and on the same side of the transversal. We call those corresponding angles. That means that they correspond to the same location with each other. So A and E are corresponding angles. C and G are also corresponding angles because they are in the same location. They're on the bottom side of the blue parallel lines. They are also on the same side of the transversal. So C and G are corresponding. So I'm going to write a few of these pairs here just so you can see it. A and E, angle C and angle G, angle B and angle F, and angle D and angle H. They are all corresponding angles. Okay, another important thing about corresponding angles is that they have the same measure. Corresponding angles have the same measure. Have equal measures. So if I have 110 degrees like I was saying up here for A, that means that E is also 110 degrees. So that is one particular special relationship that is new for you, corresponding angles. Another one, alternate interior angles. Now, what do I mean by that? Alternate interior angles means they alternate either side of that transversal. So A, C, E, and G are on one side, B, D, F, and H are on the other. But alternate interior means that they are inside those blue parallel lines. So that means they are between the two blue lines. So if they are alternate and they have to be interior, that means C and F are alternate interior angles. And E and D are also alternate interior angles. So I'm going to write those down. Angle C and angle F, and angle E and angle D are alternate interior angles. Guess what? They may look alike. C and F look like they may have a similar measurement, and you would be right. Alternate interior angles also have equal measures. So if I know one of them, I know the other. And that helps us out a lot when we are solving problems or trying to find measures of things that look like they might not be connected, because we can sometimes find a relationship like this and find the measurements that way. So alternate interior angles also have equal measures. So C and F have equal measures. The last thing, the last relationship are alternate exterior angles. Maybe you can figure out on your own what those are. Alternate exterior angles means they alternate, one's on one side, one's on the other of the transversal, and that means they are exterior to the blue lines. Well, outside of the blue lines we have G, H, A, and B. A and H are alternating on either side of the transversal. So angle A and angle H are alternate exterior angles, and angle B and angle G are also alternate exterior angles. And once again, alternate exterior angles are congruent. So we're going to write that down here really quickly, and then we're going to do a problem with this. So they have equal measures. Okay, so we learned some new things. The three things that we learned, actually we learned 4 new terms today. We learned transversal, that's the line that cuts the parallel lines. Corresponding angles, that means they're in the same location with regard to the parallel lines in the transversal. Alternate interior means they alternate either side of the transversal inside the parallel lines, and alternate exterior, alternating the transversal but on the outside of those parallel lines. Let's do a quick problem just to show you how this is useful. So if I have a new picture, and it helps if you're looking at these, sometimes they're not as easy to tell where your parallel lines are because we don't always have them drawn for us nice and horizontal. So if I have something like this and it starts to just look a little wacky to you, try to find first of all your parallel lines. I'm going to say these two are parallel, and then this is my transversal that cuts through them. I'm going to highlight that transversal just so I know where it is. Okay? Now, if I know one measurement on this picture, I can know all of the other ones. Let's say that this is 80 degrees right here. Okay? If I know that that's 80 degrees, we already know that vertical angles are congruent, and the vertical angle to that one is right over here, and it is 80 degrees. I also know that adjacent angles that create a straight angle, like 80 and this angle right over here, they have to be supplemental, which means they have to add up to 180. So 180 minus 80 is 100. That means this angle right here needs to be 100, has to be 100 degrees. Now the other one that is vertical to that is also 100 degrees, because we already know that vertical angles are congruent. They have the same measure. Now here's where we start using the new information that we have. We learned about corresponding angles. The angle that corresponds with this 100 degrees is the one right down here. It's on the top left side of that transversal with regard to the bottom parallel line. That has to also be 100 degrees. See that? This corresponds with 80. Okay, bottom left. Now let's look at another one of our, another property that we learned today. Alternate interior angles are congruent. Well, if they are alternating on either side of the transversal and interior to those two parallel lines, that means 80 and this angle are alternate interior angles, and they have to be congruent. We also know that alternate exterior angles have to be congruent. They are on either side of the transversal, and they are on the outside of the parallel lines. You used all of your properties to figure out exactly what the measurements are on this diagram. So you will be doing that in your homework tonight, and if you have any questions, as always, let me know, and I'll see you soon.